circle.
Slowly went back on. You gotta reverse it first.
Well,
Okay, real quick, let's take a quick second.
better.
Let's look at one of these. I've got a few questions about this. So machine has a power. These are so simple. What's power?
max
work
times
over
work
time.
over time.
Yeah, work over time. Amount of work done in a given time, right? But we can also do, what if this one, so this is easy, right? We just want to know if they want the most massive, the only hard part of this, you guys gotta be a little more careful about this. They're not asking for the weight, they're asking for the mass, right?
Yeah.
So when we're trying to find the work, so the work is gonna equal the force times the distance, right?
Correct.
So we need to know so that's gonna be, mg is the force, because we're looking at a weight. Weight equals mg, right? So mg times distance, which is 11.7, divided by time, which is 10.5, would equal power, right?
Yeah.
G is 9.8. So when you solve this thing, you're solving for, really what you want to do is you want to solve for M, not for the force, right? See what I'm saying? So you're gonna find, right? You ever get that? Okay. That was one that people missed a little bit. What if I am recording this one, yeah. So what if the question asked instead, say they gave you the mass of the box and they wanted to know what's the fastest that it could be lifted? How do we get that?
You just put an X in for time.
Okay, power equals work over time, right?
Yeah, and, yeah.
It'd be like,
Which is the same as force times distance over time.
yeah.
And I'm just gonna collect the distance and the time and call that a speed, right? So it equals F times V, where V is the speed, right? Now that works great if it's moving at constant speed, which these all are in these questions, right? Okay, next chapter we'll be able to deal with what happens if it's moving, if it's accelerating a little bit. We just got a couple things to cover and then we'll be done with this stuff, right? But does that make sense? Okay, next one. The other ones that people had a little trouble with, and I understand these are a little bit tricky, are, man, I paused it, I forgot to restart it on that.
Are you serious?
I'm serious.
We asked you if you were.
I know, I'm so bad about that. You guys should just do this part. I wish I should have a helper every day that just records
You
things.
should get someone that knows how to work a computer.
Knows how to work a computer.
Yeah.
I think you all know how to work a computer, don't you?
How much work can you do?
Okay, so let's see what else we got here.
Can we do one of the ones where it gives you the efficiency
Sure.
and you have to find the mechanical efficiency?
Yes.
For me, it was like the last problem.
Okay, something like that?
No,
No?
no, it's like the last problem. It gives you like,
Okay, that's no problem, right?
try number 7.
Let me see what this one is too.
Yeah, that one.
That's a good one, right?
So for this one, do you have to, since it gives you the efficiency, wouldn't you would put the mechanical over the ideal, and then you would find the ideal, and then you would like, it equals the efficiency, and then you would try to find the mechanical, and then the mechanical you would put in the other force.
Okay, well, let's talk about it. All right, here we go. Everybody up here. So, what do we got here? We're trying to find, man slides to give us the mass of the box up a 4.48 meter ramp. So that's the length of the ramp, right? That is 1.72 meters tall at its highest point. Assuming the inclined plane has an efficiency of 41.7%, he will need to push with a force of what in order to slide the load up the ramp at constant speed? So talk to me about, let's just be efficient with this. Let's be really strategic. So if we're trying to set up an equation, the efficiency equation is the one that we want here, right? So what are the ways we can find efficiency?
We can
Well, we could do a ratio of actual mechanical advantage over ideal mechanical advantage, right? I'm gonna say though let's just think about what that's gonna look like. It's not like the math is really hard, but one of the things like we do in calculus is we talk about trying to always be the most efficient we can be in doing math, right? And so, we'd rather not do a ratio of fractions if we could. Mechanical advantages are fractions, right? I mean, it's okay, but wouldn't it be easier to use the work definition here of efficiency? Where it's just force times distance over force times distance, right? Output work over input work. See what I'm getting at? Then that's an easier equation to set up and solve, very slightly, but you get the idea, right? So let's start with that. So we know efficiency equals output work over input work. And output work is just going to be output force times output distance over input work is input force times input distance. So let's fill in the blanks. Let's set up an equation. What's the efficiency?
The efficiency is 41.3.
Okay, but how do I write that?
0.417.
Equals. Okay, what's the output force? Do we know that, or is that something that we're trying to find?
Oh, that's what we're trying to find.
It is. Everybody agree with that? Anybody want to disagree with that?
Kate, disagree with us. No. That was my disagreement.
Okay,
With his disagreement.
that's not what we're trying to find. We're trying to find input force, aren't we? Right. You want to know what he's doing to the box. He's pushing on the box on the ramp, right? So that's the input force. So what's the output force?
The 31.3 times that money.
Okay, good, times G. So the output force is going to be the weight of the crate, which is 31.3 kilograms. We'll leave units off. Everything's in standard units, right?
Yeah, we don't like it.
Times 9.8. What's the output distance?
The output distance is 1.72.
Good. Right? Divided by, what's the input force?
Mass.
Our variable, right?
Yeah.
That's the unknown. Times input distance is what?
4.48.
So all we gotta do is solve for F. That's no big deal, right? We'll just, we could just cross multiply and then divide everything away that we need to, right? Agreed? So we end up with 0.417 F times 4.48 equals whatever the number on the top is.
Wait.
Right? So I'll just divide both sides by 0.417 times 4.48 and I got it.
Yeah.
Okay. Right? Make sense? You guys, this is good. You guys are getting this.
Yeah.
Hold on.
Oh, go back.
Okay. Soak it up for a minute.
Okay.
Thanks, John.
You're welcome, Kate.
Kids,
That's just
something I hate about
Dude.
It's big to compensate for you.
It's always right.
Yeah, it's not even that big, it just takes up back of the board. Not a really-
Okay, well, you're sitting
And
back
then,
behind
my
me.
favorite is just sitting right here. And I'm like, oh,
This.
And I go the other way and he's like, it's like, it doesn't-
Okay, so.
Okay, we good?
Go sit behind Ian. Grab him.
Yeah, I
You're
usually
telling
have
me
my head
I'm
down.
bad.
I usually have my head
Oh.
down.
Okay.
Where he's like opposites.
All right. Okay, last one, maybe. Tell me if you want to do this one.
Yes, sir.
Let's do a different one.
Let's do one.
Yes.
That one?
Oh, totally, yeah, that one.
Okay. Okay, this one is not bad.
Wait, mine was asking about.
Yeah,
only worth
mine
6
didn't
points.
have the angles.
Mine had the angle, but it didn't have much.
Yeah, there's going to be some variability with these too, but this basically covers what you need to know.
So this is the last one, there's 6 points, right?
Yeah.
Oh, so this one's not important.
Shh. That's the spirit.
Why are you kicking them? Cause that shit's good.
You didn't know that's a treatment, kicking around a golf ball.
Looks like one of those at-home remedies.
It's an old superstition.
It looks like one of those like at-home remedies that never work and just make it worse. Like, oh, you have a virus? Eat seaweed, it'll help. And it's like, oh, man, you got AIDS. Like, what? One of those things.
Uh-huh. Okay, so, all right, so what about this?
No.
What about this? So we know this is the same kind of thing, isn't it? So if we draw a picture, here's the box. And let's see, she's pulling at an angle. So say there's the road. The angle's 51.6 degrees, right?
Why'd you even get on?
Okay, so this is no big deal, right? We know if we're trying to find,
I thought it's zero. Is this actually recording, right?
yeah, I am recording this one, yeah. Oh, did I not put the question on there?
No.
Friction is what is, or how much friction, friction?
What do I want to know? Friction does how much work on the box? Okay.
Yes, right?
It's 49.
No. You got 50 the first time?
I got 97.
Really, anything in my grade? Well, like, I mean, I had probably like 84, now it's like 7.
Okay, let's set this up. So what's going to be, how am I going to find, what are the two forces doing work on the box here?
Gravity and.
No, gravity's doing no work on the box.
Why not?
Because gravity's pushing straight down and the box is moving in which direction? No,
Sideways.
sideways. She's sliding it across the floor, right?
Yeah.
So gravity does no work, normal
Friction.
force does no work,
Friction.
friction, and then what else?
Air resistance.
And then the work.
Tension, there we go. Okay, here's the tension vector, right? And we even know what the tension is. The
Yes.
tension is 63.3 newtons,
Per square.
right?
Yeah.
Nice.
Right?
Yeah.
She pulls on the rope with a force of 63.3 newtons, right?
Yeah.
Okay, so then all we got to do is just set up the work energy equation again. What is the box starts from rest, agreed? Okay. After she moves the box 14.2 meters, it has a speed of 4.05 meters per second. So we know what the final kinetic energy is. The net work is equal to change in kinetic energy. And the net work is just the work due to the tension plus the work due to friction, right? So let's write down, I'm not gonna do the whole thing, I'm just gonna do a little bit of this time. You guys have to figure out the rest. So what's gonna be the work due to, I guess we need to see what's going on here.
Yeah. that'd be
So-
nice.
What's the work due to tension?
Wow. Force. The force is 63.3.
Okay, I'll just call it T for now, but you're right.
Okay,
T times,
And times the distance that it's pulling.
okay, times the distance that it's pulling, I'll call that,
D sub parallel.
well, I don't even have to call it D parallel anymore because they give us an angle this time,
Yeah.
right?
Oh yeah.
50.
So you go cosine 56.
Theta, which is 51.6, I think. Yeah, right? So that's the work, everybody agree that's the work due to the tension,
Yes.
okay? Plus the work due to friction.
Yeah.
Okay, well, work due to friction is just gonna be what? Well, that's what we're looking for, isn't it?
Force.
So call that work due to friction, that's the unknown. Okay, and that's equal to, What?
Total net force.
well, that's the net work, but what's the net work equal to by the work energy theorem?
1/2 mass velocity.
Yeah, the change in kinetic energy, but it starts at 0, right?
Yeah.
And so it'd be, really it's gonna be the final kinetic energy minus 0, but we don't need to put the minus 0. So just 1/2 mv squared, right?
Yeah.
All we gotta do is solve for that, we know everything else, right? Okay, is it gonna be positive or negative?
Negative.
Negative. All right. We're
We
good?
just watch videos now.
Okay, why don't you do a little work?
I just have to take the test.
You can't
Again.
do a physics problem in 8 minutes, especially when you have to go get.
Yeah.